Alright, so this is my lab report on Lab 11, Lenz's Law and Faraday's Law. So the main goal of this lab was to both predict and observe how magnetic fields interact and affect electric circuits, and how they produced electromotive forces. This lab pretty much just consisted of a whole lot of moving a bar magnet into and out of a coil of wire and observing the changes that it had on the current within the coil. For this lab, there were 9 different activities that we were going to do to investigate the EMF. Each of the activities involved the movement of the bar magnet into and or out of the coil of wire. For each of the activities, we were observing 2 things when it came to current. It was the initial setup movement and then the secondary movement that followed. And we wanted to see what kind of EMF was produced from both movements. An example would be like moving the magnet into the coil. That was your initial setup movement, and then the secondary movement would be removing the magnet back out the way it came. That's just an example. Every time the magnet moved, it created an EMF within the coil, and that's the kind of thing that we were looking for. Since there were 9 different activities, for the sake of space, I've split them into groups of 3. So this is the first group of 3. The first activity was taking the north end of a bar magnet, sticking it into the loop from the front end, the end facing us, and then holding it still. The secondary movement was just holding the magnet still. So what we observed was that the EMF produced a force that was pointing out of the loop once we stuck the north end into the loop. And the secondary part of that was when we were just holding the magnet still. It didn't produce a EMF in that case because the magnet wasn't moving. The second activity is when we stuck the north end of the magnet into the front of the loop, the same way we did the first time. And then for the secondary movement, we brought the magnet back out. What we observed here with the EMF was that as the same with the first one, when we moved the north end of the magnet into the loop, it made an EMF that pointed back out of the loop. And then when we removed the magnet from the loop back out the way we came, it then did the opposite and made an EMF into the loop. And then for the third activity, we stuck the south end of the magnet into the front of the loop and then brought it back out again. For that, we saw that the EMF produced by sticking the magnet into the loop made a EMF that also pointed into the loop, and when we brought the magnet back out, it made an EMF that moved out of the loop as well. For the fourth activity, we stuck the north end of the magnet into the back of the loop and then took it back out again through the back the way we came. The EMF that we observed here was that once we stuck the north end of the magnet into the back of the loop, it produced an EMF that was pointing into the loop from the front, and then when we brought the magnet back out, it produced an EMF that was pointing out of the loop from the front. For the fifth activity, we took the south end of the magnet into the back of the loop and then back out again, similar to the fourth one. From there, we experienced an EMF sticking the south end into the magnet from the back, produced a EMF out of the loop from the front, taking the south end back out of the back of the magnet, produced a EMF into the loop. For the sixth activity, we stuck the north end of the magnet from the back and then pulled it through. For that, we experienced an EMF into the loop when sticking the north end of the magnet in, similar to how we did at the beginning of the fourth activity. And we experienced the EMF into the loop from the front. And then when we pulled the magnet through, we experienced a EMF that was out of the loop from the front. These are the last three activities, starting with activity 7. We had the south end of the magnet from the back and pulling it through, which produced an EMF initially out of the loop and then finally into the loop. Activity 8 was the north end of the magnet from the front and then pulling it through the back, which produced an initial EMF out of the loop and a final EMF into the loop. And then the ninth activity and final activity was taking the south end of the magnet from the front, sticking it in and pulling it through, which produced an EMF originally into the loop and then finally out of the loop. The main conclusion from this is that if you imagine the arrow pointing into the south end of the magnet, the EMF is going to do the opposite of what that arrow is doing. So if the arrow is pointing towards the loop, it's going to make a EMF that's going to point out of the loop. So sticking the north end of the magnet into the front of the loop means that the arrow pointing into the south is also pointing into the loop. So the EMF is going to be the opposite of that. It's going to push out of the loop in response. So yeah, that's just about it.